Being isolated from people is so great. I never really understand what they are thinking anyway. So today I built a small system that can help me with that.
Hey, from street camera, I can click on people and see what they are thinking. In this video, I'm going to show you how to do it.
I'm going to walk through a small interactive video project that I built using SAM3 and a local LLM. So the goal was simple. Click on a person in a video, segment and drag them, and attach a short inner thoughts text bubble generated by an LLM. But there was a constraint. I'm GPU poor and working often remotely, so this system is designed to be GPU poor friendly and bandwidth controlled. So instead of running heavy full video tracking, everything is windowed, cropped, compressed, and optionally sent to a small GPU server. You can build the same on your own computer if you have GPU. It will be way easier. So I walk through the full practical pipeline from the reading the video, handling the click, preparing the frame, sending it to SAM3, getting the mask back, tracking over a short window, and attaching the text bubble. So let's start with the structure. We have two main parts. The client side, so basically it's the interaction and video handling, and the server side, which will be the SAM3 execution. So you can check in the folder just here. For the client side, it would read the video, handle the clicks, prepare the crops, and send requests, and finally draw mask and bubbles. On the server side, it's more simple. It's basically run SAM3 on GPU, manage a segmentation station, and return the mask, of course. So this, and we have also our player just here. It's where everything starts. So we need to read the video and handling clicks. So here is the video reader here. I read each frame once and store it. So later interaction is instant when I click. So now the actual player loop is down here. So here in the player, I open the video using OpenCV just here and load the frame just over here. Here, nothing fancy, just reading the frames and keeping them in memory, so interaction is instant. When I click, I get two things. I get frame and also the coordinates. So the important part here is the click handler. Just over here, this is where the whole pipeline starts. So when I click, I got two things. First, the coordinate, the positions here, and also the frame index where I clicked. So that's exactly what SAM3 needs to know where to segment.
Before going further, let me explain what SAM3 is. It stands for Segment Anything Model. It's a foundation vision model trained to perform image segmentation from minimal prompts. That means, instead of drawing a bounding box manually or training a custom detector, I can just give it sparse signals like click or points and it predicts a clean object mask. It's trained at scale, so it generalizes extremely well across different scenes and object types. If you want to try this yourself, you can just check the SAM3 GitHub repo. The docs are clear and it's straightforward to plug in. Also, if you want to know more about it, you can just check Yasin's video.
So normally you could set just one click point to the segmentation model, but it would be terrible. It would be difficult to detect anything. So here I cheated a little bit. Instead of sending one exact point, I generated a small cluster of nearby points around the click. And then segmentation can be more stable in that way. And edges are cleaner and the mask doesn't break as easily. So one click from the user is small point cluster sent to SAM3. And let's switch to the SAM3 side. So in the script, we receive the information from the click. So let's check quickly. You can see just here, we have our click. We had positive points around the click, so we have many of them. But also we use text prompts. So here I added the word human because it's related to this project, but if you have like another one, you can try with other words. It would help the model finding what we want to track. So now let's see how SAM3 works. Now that tracking gave us the mask and the bounding box of the person, I also generate a short text thoughts that will appear inside the bubble. So this is done with a small language model, not a big one because we only need one short sentence, not like a full paragraph. So we can see just here, I use Qwen and with 0.5 billion parameters, which is like quite small.
You can find it directly on Hugging Face. That's where most open language models are shared along with their wave and documentation, so you can browse different size, compare versions, and just plug them into your pipeline.
So the prompt template is defined just here on the server side. It's basically a short instruction that tells the model to produce a quick inner thoughts for the clicked person. The tone is fully controlled by this prompt. So if you change the wording here, the personality of the generated thoughts changes too. So I tasted like a few style, and for this one, my people are from the ghetto. I don't know why, they sounds like kind of depressed, but it's fine, I like it. I'm from the ghetto. My life is tough. I'm just here for the hustle. I live in a small apartment. I think for this part, it's quite fun to experiment a little bit. If the LLMs fails or times out, tracking still works, and we can just use a fallback, what I used here with these two sentences, and it will fill the bubble. So now, once we have both the bounding box and the generated text, the bubble is drawn just here, directly in the player. So this function builds the bubble shape near the tracked person. This position comes from the tracking bounding box, so as the person moves, the bubbles follow automatically. And here, the text is rendered inside the bubble using standard OpenCV textually. The roles are cleanly separated. Tracking gives position, LLM gives the sentence, and the player draws the bubble. Each part is independent. You will notice that when I click, the video slows down slightly. That's intentional. SAM3 plus the server round trip takes around a second to return the first mask. So instead of freezing or jumping visually, I slow down playback right after the click. It helps to cheat a little bit. This makes the interaction easy to follow and hides the compute delay in a natural way. So it's partly UX, partly timing control. Another practical choice is that I only track a short window after the click, not the full video. There is no reason to track someone for a minute if the interaction is local. And this keeps the GPU cost, bandwidth, and latency under control. So the full pipeline is click, SAM3 segmentation, short window tracking, bounding box, LLM thoughts, and bubble overlay. It's a small project, but it shows how interactive segmentation, tracking, and language models can be combined in a real pipeline. You can extend this to other projects, different prompts, different bubble styles, or different behaviors. And maybe one day, instead of random generated thoughts, a system like this could generate very accurate ones, given how much data already exists online. Thanks for watching my first video. I hope you enjoyed it, and I will leave you with a small music moment from Yasin to close this out.